Hi there. Today we're finally going to learn about core data in SwiftUI, and we will mainly focus on three things. First, we want to know what core data is. Second, we want to understand the core data stack. And lastly, we want to be able to create a core data app with basic create, update, and delete functionalities from scratch. So without any further ado, let's get straight into it. So first of all, what is core data? Core data is a native solution provided by Apple to store data permanently. Now, what I mean by native solution is that it is an Apple-specific framework and you can't use the stored data on, for example, an Android device. However, it is also available on Mac OS and other Apple-specific platforms. There are also some other use cases that are worth mentioning, such as caching data. Now, this could be useful if your app does a lot of network requests and you want to cache the responses so you don't exhaust your server with too many requests. Further, it also provides support for redo and undo. Now think of a painting app where you're starting to draw something and you want to undo the changes or redo the previous steps. Core data makes it really easy to keep track of these changes so that you can provide these functionalities to your users very easily. So core data has basically two big responsibilities. First of all, it has to be an object graph manager. And secondly, it has to provide persistence. Now, what does it mean to be an object graph manager? Now, let's say we create an app that stores our favorite movies. Now, if you would think about the models in this app, obviously there's going to be some kind of model that represents the movie, but there may also be other models that represent the genres and the actors. Now, in a more complex app, you might even be able to filter out movies by genres or actors. Therefore, there's also a relationship from the genre back to the movie, and similarly from the actor back to the movie as well. In fact, these relationships can be quite different from movie to movie. So if we have multiple movies, some movies may belong to multiple genres than others. Some movies may have more actors than others. Obviously, the relationships will get more and more complex as the user goes through your app and creates more movies. Core data basically takes care of keeping track of these relationships between these models, so that when you shut down your iPhone or even close your app completely and open it again, it will still know the relationships and can restore the state such that the user does not have to add all the movies he added previously again. Now, the second main task is the persistence. Obviously, it's not just enough to just create a graph of all of these relationships between our models, but we also have to be able to, for example, store it on the iPhone's flash drive and retrieve it when we want. So the persistence layer of core data takes care of this for us. Now let's look at the core data stack. As I mentioned before, there are two main tasks, and all these classes in the core data stack belong either to the object graph management or to the persistence layer. So let's start with the object graph management layer. Now, to represent the object graph management, there is something called the managed object context. And inside of that managed object context, there are multiple managed objects. Now, what do I mean by managed objects? Well, let's take a closer look at this managed object context first. So remember, in our previous example, we had an app where we had the models movie, genre, and actor. Now, in terms of the core data stack, these are also our managed objects. So instead of just creating a struct for movie, genre, and actor, we would have a class that conforms to the managed object such that it is capable to be managed by core data. And all of these managed objects belong to at least one managed object context. However, it is possible that you can have multiple managed object contexts, but this is rarely used in practice. Now, the way these managed objects are created has also changed. You do not manually create these classes yourself. Instead, you use the Xcode's data model editor that is built into Xcode. And for that, you have to create a new data model file and make sure that the managed object context knows about this file as well. We will have a closer look at this in a bit. Now, besides the object graph management, there's also the persistence layer. Now, on the persistence layer, we have the persistence store, which is responsible for storing our data onto the flash drive, but also retrieving it back in a format that can be read back. Now, for the communication in between, there's another layer that is called the persistent store coordinator. Persistent store coordinator takes care of the communication between the managed object context and the persistent store. So there is no direct communication from the managed object context to the persistent store. Now, working with the core data stack became really easy throughout the years. In fact, with SwiftUI, I would argue it became even more easy than it was before. So what changed with SwiftUI? Now with SwiftUI, a few things changed. First of all, the NS managed object now conforms to the observable object. Remember, our movie, actor, and genre models are of type managed object, and therefore they also automatically conform to the observable object as well. So if they change, our views can also get updated automatically. Second, there's a new property wrapper called add_fetch_request, which makes fetching and displaying results in our views very easy. Lastly, the managed object context is now included in the environment. Now, if you do not know what the environment is, I strongly recommend you to watch my video on this, and it will make much more sense to you. Now let's go into Xcode and create a new project to get a better grasp of how the core data stack works with SwiftUI. Alright, now open up Xcode and create a new project. Make sure you select app, press next and give it a name. I will just call this one to-dos list, and make sure the interface is selected to SwiftUI and the language set to Swift. Do not select use core data because we're going to create it from scratch ourselves. So press next and save it somewhere you like. Now once you're in Xcode, make sure you select the iPhone 11 as your simulator. Also try to resume the automatic preview. Now the first thing we need to do in here is we have to think about our data models. Obviously our to-do list contain multiple tasks that we have to finish. So let's start by creating a model for our tasks. Now the way we do that is we go to File, New File, and there we scroll down all the way to the core data section and we select the data model template. Now we have to give it a name. I will simply name this one to-do list and press create. Now this will create this to-dos list.xc data model D file for us. And in here we can create our entities, which basically represent our NS managed objects. So let's start by creating an entity. The way we do that is we select this add entity button, and then we go in here and give it a name. So I will simply call this one task, and we can also give it some attributes. So a task might have some kind of title, and that title is going to be of type string. Further, it might also have a date, and the type for that would be date. Now make sure you save by pressing Command S. And as soon as we created this entity, Xcode will automatically create this NS managed object class for us. And to show you where this is happening, I would like to go back to the content view. And in here, I'm going to say import core data. And I will simply create a test struct like so. And I will create a task instance like so. Now it could happen that you get this error message like I do, and this seems to be an Xcode bug, and the only way you can fix it as of now is by simply shutting down your Xcode completely and restarting it. Alright, I restarted my Xcode, and now as you can see the error disappeared, and if I command click on the task and jump to the definition, it will find the file. And here you can see that the task that was created for us conforms to the NS managed object protocol. Now this file was automatically generated, and you should not edit this file. I think you can't even do that because it's read only at this point. Now as I mentioned before, this NS managed object conforms to the observable object protocol, and to prove you this point, let's go back to the content view and create a new class. And I will simply call this one test2, and I will make it conform to the NS managed object. And the proof that it is also an observed object is that it has the object will change property, which obviously comes from the observable object. Now let's remove all of this and start using the core data stack. Now for this we are going to create a new file. It's going to be a Swift file, and I will name this one persistence. Now inside of this file, we're going to create a struct, and we will call this struct the persistence controller. Now we're going to use this to access our persistent container. And what the persistent container basically is is a container that encapsulates the core data stack in our app. So it simplifies the creation and management of the managed object model, the persistent store coordinator, and the managed object context. So instead of creating these, initializing them ourselves, we can simply use this handy persistent container. So let's start by using it. Now we will use the singleton pattern for this. So we will create a shared instance that will be initialized with the persistence controller. Now in here, we're going to access our containers. So let's create a container property, and it's going to be of type persistent container. Now Xcode won't find it because we didn't import core data yet. So make sure you replace import foundation with import core data, and Xcode should be able to find it. Now Xcode is complaining that we never really initialized this container. So let's create an initializer for this. And in here we have to initialize it as follows. So our container is going to be an NS persistent container that we initialized with the name. And the name is basically going to be the first part of your Xcode data model D file. So in this case, to-do list. So let's just type it in here. So it's going to be to-dos list. Now the second step would be to load the persistent stores. And the way we do that is by simply saying container.load persistent stores. And here we have a completion handler that gives us the store description and the error. So let's use them. Now for now, I won't do the error handling. I will simply say if there is an error, give us a fatal error. So I will say if let error be equal to the error, and we have to make sure that we can cast it as an NS error, like so. And here we will simply have a fatal error saying that we have an unresolved error, and we will simply print out the error in here as well. Now you can look up what this load persistent store does. So basically it instructs the container to load the persistent stores and therefore also completes the creation of the core data stack. So if this succeeds, our core data stack is ready to be used. Now what we need to do is we have to make sure that the environment where the managed object context is stored knows about our current NS managed context, and we can access it through this container. So let's set this environment by going into the app, and right after content view, we are simply going to say environment, and the key path is going to be managed object context. And here we have to pass in the managed context that we can get from our container. So let's first create an instance here. So we will simply say let persistence container be equal to the shared instance of it. And in here we can then access the container like so. And the context can be retrieved by the property called view context. Now that we set the environment here, we can go into the content view and read from this environment, because the content view is obviously a child of this app. So we go in here and then create a property wrapper called environment. And in here we have to pass the key path. So it's going to be managed object context. And we are going to store it in a private variable called view context. Now think of this context as some kind of scratch pad. So if we create a to-do list, it's not enough to just notify the context about the changes, but we have to also store it using the save method on the view context. Now next we want to keep track of all the tasks that are stored so we can create a list out of them and present it to the user. So let's create a variable called tasks. And it's going to be of type fetched results with the generic type of task. Now Xcode will complain here because we never really initialized tasks. However, there's this handy property wrapper that takes care of this, which is called fetch request. And fetch request takes the sort descriptor, which we won't choose for now. I will just leave it empty. But here you could, for example, tell it to sort by the date or by the title alphabetically, and whether you want it to be sorted ascending or descending. Now, as soon as we add this property wrapper, you will notice that Xcode stopped complaining. In fact, we can also go further and declare this as private, and it should still be fine. Now, let's go to the UI. Let's create a list of all the tasks that are already stored. Now, for that, I will create a navigation view. And inside of that navigation view, I will create a list. And inside of that list, I will have a for each loop that goes through all the tasks that we have. And we will get back the task in here. And what we will do here is simply create a row as a text. So I will say task.title. Now this is optional. If there is no title, I will just name it untitled. And I also want to give this navigation bar a title and a button that we can use to create a new task. So let's do that. Now, whenever this add task button is tapped, we are simply going to call a function that takes care of this, and I will define it in a bit. So after the body, we create a new private function called add task. And in here, we are going to create a task as follows. And the way you do that is first you initialize a new task. So you simply say task. And the task will require a context, and the context is going to be our view context that we read from our environment. So we pass this in here. Next, we can initialize our task, so we can give it some title. Let's simply say new task, and also give it a date. And we want to also give the task a date. I'll make sure that you initialize the date here, like so. Now here we just created the task and told the view context to track of it, but we didn't tell it to save the current progress. To save the current progress, we have to tell the view context explicitly that it should save what was changed before. And the way we do that is by saying view context .save. However, this function will throw, because sometimes it may not work, because for example the user may not have enough space on his phone or because of some other reasons. And to catch these error cases, we will do a do try catch. So we will say do, and in here we are going to try to save, and if it doesn't work out, we're going to catch the error, and we will simply say we will class the error as an NS error, and we will simply throw a fatal error. All right. Now, since we have to do this every time when we do some changes, it makes sense to have a separate method for this. So I will create a new method called saveContext, and in here I will paste all of this, and instead of having it in the add task, I will simply just call saveContext. Now let's run this and see if this works as expected. So here's our to-do list, and if we add in tasks, you can see the new task was created, and we can create multiple tasks. Now what happens if we close the app? So let me close this and open this again. You will see they are still stored. Perfect. However, it looks kind of abrupt. The rows are added in a way that it doesn't really feel natural. So it would be nice if the inserting is animated. And the way you do that is by simply putting this into a with animation closure, like so. and you simply put all of this code inside of it. Now let's try this again. And this time if we add a task, you will notice it gets animated and it looks much nicer. Now that we know how to create a task, let's also figure out how to delete a task. Now, the way you do that is inside of the list where you have your for each, you can create a function for the delete. So whenever the user swipes a row, you want to execute a specific function. And the way we're going to use it is we're going to say on delete, perform, and here we will pass the function that we will create in a bit. So let's create this function down here. Now Xcode will complain here because the perform also passes an optional index set that basically tells us of the exact rows that are intended to be deleted. So let's modify our delete task method as follows. We will make sure that it also takes an offset of type index set, and Xcode should be fine here. Now we want the deletion to be also animated, just like the insertion. So inside of the closure, we can do the actual deletion. And the way you perform the delete is using the view context dot delete. And then you have to pass in all the objects at the given index set. For example, if the first, second, and third elements should be deleted, you would have 3 lines of these with the specific object at the specific index. However, there's an easier way to do this, and let me show you how this is done. So you say offsets.map. Now the $0 represents all the indexes inside of this index set. So what we really want is the individual elements in the task array. So we say $0. And for each of these, we want to call the view context dot delete. Lastly, we have to make sure that we call save context, and let's see if this worked. Now if we swipe, you will see this delete option, and if we press delete, it seems to delete it. Actually, you can also do a long swipe to delete it like this. Now let's close the app and see if the deletion was actually saved. Let's open the app again, and you can see it really removed all the to-dos for us. Lastly, I would like to look into how to update a task, and for that I will simply create an on-tap gesture on the text, and whenever the title is tapped, I'm going to call the method update task with a task, and we are going to create this method here as follows. Now to update the task, we need to know the type of the task, and if you comment this out and look up what the task is, you will notice it is of type fetch results over the generic type task. So we can just copy this type, uncomment this again, and then in here we will simply say the task is going to be of that specific type. Alright, now how do we update? As always, we do it inside of an animation closure. And let's just update the task that we get passed by renaming the title to update it as follows. And then we will simply call save context. And let's run the app and see if that worked. Let's try to update one. Let's update the middle one. All right, now let's close the app. And as you can see, even the updated task was saved correctly. All right, now one last thing I would like to show you is how to sort the tasks. Now you can sort them by the date. And the way you're going to do that is by passing an NSSort descriptor. And there's one that takes the key path and whether it's ascending or not. And the key path is going to be our task key path. So we will say task.date. And we do not want it to be ascending, so we say false. And if we run the app, you will notice that it is also sorting it for us. So all the new tasks will be added on the top. And if we close and reopen the app, the sorting is also kept. All right, now this is really all I wanted to show you in this tutorial. As you can see, it is not that difficult to use Core Data with SwiftUI. I hope this was helpful for you. Make sure you subscribe to the channel so you get notified when new content arrives, and I will see you in the next tutorial. Thank you for watching.